Moving on then, the next thing we're going to have a look at is solving equations. Now, this tends to be the higher end of the foundation tier. They're all linear equations, which means you haven't got any squares or anything like that involved. So solving linear equations, we're going to have a look at two. We're going to have a look with x is on one side and then x is on both sides, which is the hardest type. Now, x is on one side, you get two types of this. You get something like x plus 3 equals 11. That's pretty straightforward. There is a method for doing it, but you can just literally try numbers in place of x and see if it works. So what add 3 is 11, and eventually you're going to get to 8. 8 add 3 is 11, so that works. We're going to look at the two-step ones, where you've got a number in front of the x, then another add or take away, and then an answer to get to at the end. So this is slightly harder. You can still guess these, but if they give you a really tough one where the answer could be a fraction, you're not going to be able to guess them. So you do need to have a method that you can try. Now, the way I teach this tends to be using a function machine. You can do it various different ways. And obviously, if you're confident with another way, keep to that. But I think this is the easiest way to sort of explain what's going on. So 2x plus 6 equals 14. So I always sort of try to think of it as a story. I start with x. What's happened to it? How does the 2 come in front of it? Well, number and a letter joined means I times. So 2 times x, or x times 2. So it's being times by 2. That's how the 2's come in front. So start with x, then I times by 2. Then the next thing, I've done that. I add on 6. And then it tells me my answer is 14. So that's basically what's happened to my function machine. I start with x, I times by 2, I add 6, and then I get to 14. Now, to find x, we can work backwards. So we start at 14. Opposite now to add in 6 is take away 6. Because we're working backwards, we're going the opposite way. Opposite of timesing by 2 is dividing by 2. And then eventually, we're going to get the answer of x. So 14 take away 6. You can write that in as you go. Is 8. 8 divided by 2 is 4. So underneath, x equals 4. Now you can use substitution now to check your own answer. That's the good thing with algebra. 2x means 2 times x. If x is 4, 2 times 4 is 8. 8 plus 6 is 14. Yes, it does work, so it's correct. Second one then, x is on both sides. You can use the function machine to do it. We're just going to have to do one step first, though, before we can do our function machine. When you've got x's on both sides of the equal sign, you can't do your function machine straight away. It won't work. So what we need to do is get to a situation where we've got x's on one side, and then on the other side, we've only got numbers. So we're going to try and put all the x's on one side. Now, the way to do this, you always want to pick the side with the most amount of x's. Okay, but so what I mean by that, I'm going to try and get all my x's on the left-hand side, because on the left-hand side I've got 5 x's, and on the right-hand side I've got 2 x's. So it's easier for me to move my 2x than it is my 5x. So to get rid of that 2x, that's my problem there, I want that over the other side. To get rid of it, get rid of 2x, you do the opposite to it, so you take away 2x. And notice I've done it to the other side. Think of algebra as a weighing scales. Whatever you do to one side, you have to do to the other. So that was my problem, the 2x, so I wanted it on the other side. To get rid of it, I do the opposite. I take away 2x, and then I make sure I do exactly the same to the other side so that I keep it fair, keep a good balance between the two. 2x take away 2x is nothing, so that just disappears. 5x take away 2x is going to be 3x. So 3x plus 2 stays there, 11 stays there, I haven't done anything to that. 3x plus 2 equals 11. That's my new equation. Now I can go about doing it using my function machine. Start with x, what's happened to it? Times by 3, that's how the 3's coming from. Add 2 and I get to 11. Work backwards. Opposite adding 2 is take away 2. Opposite times in by 3 is divide by 3, and then I get back to x. 11 take away 2 is 9. 9 divided by 3 is 3. So x equals 3. Make sure you write it down like I have on the bottom line. X equals something. You want to tell the examiner, you know what it is. You're saying x is equal to this number. Again, you can check your own answer by substituting it back in. So if you put it back into the top one, 5x means 5 times x. 5 times 3 is 15. Add 2 is 17. So on the left hand side we got 17. On the right hand side then, 2x is 2 times x. 2 times 3 is 6. 6 add 11 is 17. So the left equals 17, the right equals 17. Does 17 equal 17? Well, yes it does. So, summary with this, the top half, when it's in that form, all the x's on one side, none on the other. You can start with your function machine straight away. Bottom half, when it's in that form, you've got x's on both sides. What you need to do, think which side you want to get all your x's on. Always the side with the biggest amount of x's, so my 5x's this time, sorry. And then to get rid of the bit on the other side, you do the opposite. But remember, you have to do exactly the same to the side that you're trying to get all the x's on as well.